This is a video looking at alpha, beta, and gamma decay. Okay, so radioactive decay is basically when an unstable nucleus, an element that's got an unstable nucleus, let's say like uranium, when it decays, when it breaks down. That's what the word decay means. Reason being it decays is because of too many neutrons in its nucleus. So the more protons, the more neutrons you add to a nucleus, the heavier it gets, and the forces start to become imbalanced, and it starts to decay. So I'll start off with alpha decay. So alpha decay is basically when an unstable nucleus releases an alpha particle and becomes a lighter element. So this is the whole idea of radioactive decay. You've got a big element, let's say a big nucleus, decaying into something smaller, okay, because it's breaking down, and it releases energy in the process. What's an alpha particle? An alpha particle is another word for helium nucleus. A helium nucleus, if you look on the periodic table, it's got 2 protons and 2 neutrons. Okay, it's got an atomic mass of 4. Atomic mass is a measure of how many number of protons and neutrons it has. Okay, so in the case of helium, it's got an atomic mass of 4 because it's got 2 protons and 2 neutrons. Now, nuclear physicists write it like this, okay? He for helium, 4 at the top, 2 at the bottom. 4 is the atomic mass. So in radioactive decay equations, they put atomic mass at the top, the bigger number. At the bottom, that's the atomic number. Okay, that's how many protons or electrons it has. So helium's got an atomic number of 2 because it's got two protons in this case. Or they sometimes write it like this. They sometimes write it with a funny A. This is called alpha. Alpha is the first letter of the Greek alphabet. Let's see how this works. So let's suppose we've got uranium. Okay, it's got an atomic mass of 238, atomic number of 92. How do we work out the radioactive decay of this? Okay, the alpha decay. Let's suppose you're asked an alpha decay question. First thing you do, so this is like an equation, you have to balance it. It's like a seesaw. First thing you do, write down an alpha particle, okay, if it's alpha decay, plus something else. It's a lighter nucleus. How do we work out this something else? Well, it's quite simple. It's simple math, simple algebra. 4 plus something gives you 238. Okay, so that number will be 234. Okay, 234 plus 4 is 238. Something plus 2 down here, something plus 2 is 92. That's 90. That's the hard bit. Easy bit, just go to the periodic table, look up the element with atomic number 90, and you'll find that it's thorium, Th. And that's it. That's how you do it. Let's do another one. Let's do the alpha decay of polonium, PO, atomic mass 218, atomic number 84. Just like before, it's a seesaw, it has to be balanced. Okay, so this, I should mention also, this arrow means decays into. Okay, it becomes something else, decays into. So polonium becomes an alpha particle, that's right, let's use this symbol, alpha, plus something. Now, 4 plus something is 218. Okay, that will be 214. Something plus 2 is 84, that's 82. Okay, if you go to the periodic table, you'll find that it's Pb, it's lead. Okay, that's alpha decay. Let me now go on to beta decay. Beta decay is when an unstable nucleus decays into a beta particle and a lighter nucleus. Okay, it's pretty much more or less the same idea as alpha decay. It's a bit different. What's a beta particle? A beta particle is another way of saying electron. Okay, so E for electron. It's got an atomic mass of 0. In other words, its mass is more or less 0, even though it's not technically correct. Electrons do have mass, but for the Year 9 syllabus, just let's pretend that it's got a mass of 0. Its atomic number, i.e. its charge, is -1. Okay, that's why it's minus down here, -1. Or we can write it like this. It's an extended B, that's called beta, second letter of the Greek alphabet. So let's see how this thing works. Let's do beta decay. Let's do an example. Let's do the case of uranium, this time with atomic mass 235, atomic number 92. What does it decay into? Okay, let's suppose you're given a question on the beta decay of uranium-235. What does it decay into? Well, let's write down the beta particle. Now, here's what I would do just to make it a bit easier. Put the beta particle here, the electron. Something plus 0 is 235. Well, that's 235. Something minus 1 is 92. That's 93. Go to the periodic table, and you'll find that it's the element Neptunium, Np. That's how you do it. Let's do another one. Let's do iodine-131. The beta decay for this. How do we do it? So it decays into an beta particle. Let's use this symbol. So something plus 0 is 131. Well, that's 131. Something minus 1 is 53. That's 54. If you go to the periodic table, what element has atomic number 54? That's xenon. X sub E. Xe. And that's how you do it. That's beta decay. Last one, let's do gamma decay. Gamma decay is actually the easiest out of all of them. Okay. If you forget everything else, don't forget everything else. Don't forget gamma decay. Gamma is actually the easiest. Okay. If you don't know how to do beta or alpha decay in an exam, you should be able to do gamma decay. It's the easiest. Why? It's when an unstable nucleus releases energy. That's it. Okay, the nucleus doesn't, the element doesn't change. It stays the same. What do I mean by that? Well, let's suppose I've got technetium 9943. Oh, before that, actually, I should mention what a gamma releases energy in the form of a gamma ray. Now, if you think back to the electromagnetic spectrum, a gamma ray is a high energy form of light. Okay, it's given the symbol gamma, alpha, beta, gamma. Gamma is the third letter of the Greek alphabet. It's got no charge, no mass, no charge, no atomic number. So that's how you write it. Okay, it's very simple. EG 99. Let's do technetium 9943. Okay, so something plus 0 is 99. That's 99. Something plus 0 is 43. 43. Technetium, you get the same element back. Okay, it's very easy. Let's do another one. Let's do californium. Let's do 248, 60, 96 cm, 00 gamma. Something plus 0 is 248. That's 248. Something plus 0 is 96, 96. You get back the same element. And that's the idea. So with gamma decay, the element doesn't change at all. Beta decay involves a beta particle, an electron. Now, I should also mention, technically speaking, there's another type of beta particle called a positron, which looks like this, but that's not part of what you need to know for the syllabus for year 9. So don't worry about that. And an alpha particle is just a helium nucleus, and that's how you do the equations for radioactive decay for alpha, beta, and gamma decay.